Okay, so in this video, we want to go ahead and look at finding the following limit. Now, when we talk about limits, what we want to know is take the limit as whatever is happening down here. In this case, we want to say as x goes to 2, and that's what this arrow represents. What's the limit as x approaches the number 2 here? So to do that, what we want to do is we could, if this would work out, we could just plug in 2 for every x and simplify. Unfortunately, that doesn't work because if you plug in 2 for everything here, that's going to give us in the numerator 2 cubed minus 2 times 2 squared all over 2 minus 2. And when you simplify both the top and the bottom, you're going to get 0 over 0. And that's undefined because we have 0 in the denominator. But even more important, because this is 0 over 0, this is telling me that something else is happening other than the limit not existing. Now, the limit may still exist because of some weird things with limits. So we're not wanting to know what is it when you actually plug this in. We're wanting to know what's this function doing just as x is approaching 2 from the left, and what is the function doing as x is approaching 2 from the right. So to see what's happening here, we want to go ahead and look at both the x and the y here, and we want to just figure out some different values of x to plug in. So to see what's happening, I want to look at what's happening as x approaches 2 from the left. In other words, on the number line, I want a number that's relatively close to 2. So I'm going to say that that's 1.9. So that's the first number I'm going to look at. But then I'm going to look at 1.99. And after that, a little bit closer, of 1.999. Now notice that as I'm getting closer and closer and closer to that number 2, I'm looking for what's actually happening to the y value. And that's just from the left-hand side going towards the right. I hope that looked right on there. I don't think it did. So from the left-hand side going towards the right, maybe. One of the two. Anyway, now we want to look at what's happening as x approaches 2 from the right-hand side as well. So to do that, we would start over here. And, we would say maybe 2.1. 2.1 would be a good one to look at. And then we could look at, say, 2.01. And then, say, 2.001. Now, notice what's happening here is I'm getting closer and closer and closer to the number 2 here. So I'm not actually going to use 2 as part of my table because, as you saw, if you plug in 2, you get an undefined value. Okay. So in order to figure out what this is, we want to go ahead and just use the calculator to figure out these values. I could just write down the values and tell you what's happening, but it's best to see it from the calculator. So what that means is I'm going to go ahead and end the video. Well, I'm not going to end the video. I'm going to go ahead and switch to the calculator for us to see. I'll see you there. So now that we're here at the calculator, let's go ahead and see what we can do with this. So we want to figure out what is the limit as x approaches 2 of x cubed minus 2x squared all over x minus 2. So what I want to do is I want to go ahead and type in the function into y equals. So click on y equals at the top left, and then we want a big fraction, so make sure we do alpha y equals enter. Otherwise, if you don't do this, it's going to come out wrong, more than likely. So what we would do is we would have x cubed, x and then caret 3, right arrow, minus 2 and then x squared. Good. Use right arrow to go down to the denominator, or down works as well. And then just x minus 2. Awesome. And again, x is just right here. Now, here's the thing. If I quit to the home screen, notice if I do vars right 1, enter, enter, that's going to tell us y1. If you click enter again, it's going to give you some random number here. And it won't be probably 100. It'll probably be something else. Instead, what we want to do is go to vars right 1, enter, enter. But then open in parentheses, we're going to use function notation here. And we're going to say, what is this as x goes to 2? In other words, what is the function value at 2? But notice that it says we're dividing by 0. And that happened because it's technically 0 over 0 here. So this numerator becomes 0, the denominator becomes 0. So this is 0 over 0. That's undefined. That's the reason it doesn't work. Instead, though, let's go vars right1 enter enter, open a parentheses, and this time we're going to ask it what was it for 1.9. So do 1.9 and click enter. That tells me 3.61. Okay. Now let's go to vars right1 enter enter, open a new parentheses, and now let's do 1.99. Notice this is saying what is the function at x being 1.99. That gives me 3.9601. And again, go vars right1 enter enter, open in parentheses, and let's do 1.999. Enter. And we wanted, and that's giving us 3.996001. Now, notice that if we did this one more time, this is going to give us 3.9996001. So do this again. I didn't put this one on the, or in the notes, but that's fine. So one more 9 here. 3.9996001. Now, notice what's happening as x gets closer and closer and closer to the number 2 from this left-hand side. It started up here at 3.61. Then it became 3.9601 and 3.996001 and 3.9996001 and so on and so forth. So as we add on more and more 9s here, we're going to add on more and more 9s here. So this is getting closer and closer and closer to that number 4. Now, let's go with the numbers that start from the right of 4, and the right of 2 and goes to 2. So the first number that we have here is, so vars right1 enter enter, open new parentheses, we're going to do 2.1 was the first number, which is 4.41. Excellent. Then goes vars right1 enter enter, open new parentheses, 2.01 is 4.0401. And then do this again. You may be able to guess what's going to happen. So 2.001, click enter, and that gives us 4.004001. Now notice that if I add on another 0 here, it would give us 4.004001. Excellent. Exactly what we were expecting. Notice that as x gets closer and closer to the number 2 from the right-hand side, this is getting closer and closer to the number 4 as well. So from the left, it's getting close to the number 4. From the right, it's getting close to the number 4. So then it would be 4. Now, here's the thing, though. Let's graph this. I need to go to the standard window here. Good deal. So at 2, notice that it looks like the number 4 is going to be there. But here's the thing. The reason that this is happening, and it looks like it does here, and it doesn't look like a rational function, is because there's actually a hole in the graph. And it's kind of hard to see because you actually can't see it from this far out. But I'm going to go ahead and change this window from 1.99 to 2.01 for the x's. And for the minimum, let's say 3.99, and the y max would be 4.01. And then graph this. Notice that now you can actually see the hole in the graph that is created by the calculator. So it's basically saying that there are holes here, or there's a hole here, because when you have x equaling 2, you're dividing by 0. So that's what's happening. But notice that as x approaches 2 from the left, it's going close to the number 4, but from the bottom. And then as x approaches 2 from the right, it's getting close to the number 4, but from the right-hand side as well. And that's what we really need for limits. As long as the left-hand side, or I think for you it would be the left-hand side, approaches the right-hand side, and they approach the exact same value, then that limit exists, and it's whatever it's approaching. Notice that in this case, the function value does not exist. So the limit actually does not depend on the function value existing for the limit to exist, which is actually pretty interesting. Alrighty, I'm going to go ahead and go back to the notes here. Okay, so as you can see from the notes that I've written here already, all I've done is I have written down what's the function value as x gets closer to 2 from the left, what's it doing as x approaches 2 from the right. Now, I do want to emphasize how we write this down, or at least how we can write down each of these one-sided limits that we were looking at there. So we have, for the limit, as x approaches 2 from the left-hand side, that's what that negative as an exponent there means. It's not really an exponent, but that's what it looks like. Of this function of x cubed minus 2x squared all over x minus 2 is equal to, notice that this is approaching the number 4. Then we also have the limit as x approaches 2. Now from the right-hand side, all we do is we say that it's a plus there. And then we have x cubed minus 2x squared all over x minus 2. That's also equal to 4. So x approaches 2 from the left, x approaches 2 from the right. Notice that the left and right are the same thing. Therefore, the limit as x approaches 2 of the function x cubed minus 2x squared all over x minus 2 is 4. And there you go. Alrighty. Well, I believe that's it for this video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.